Hi everyone, Jaxiro here. I'm a software developer and currently I'm venturing into Flutter. I've been using Flutter for the past 2 years as a mobile developer, and of late I'm venturing into desktop just using Flutter, having been from my .NET framework, and I saw Flutter is offering a lot of flexibility and portability. So Flutter seems to be the best thing on at the moment that is able to give your app the portability that it requires. And I even saw in the recent Flutter Forward event that they have new updates that are coming up, and they are they are supporting Flutter desktop just the way they have been supporting web. And this session is just going to highlight in a nutshell how you can make your app to be portable on whatever platform that it will be running in. So welcome on board, and I hope you're going to enjoy this session, and we'll be able to get something out of it. So let's jump right in. So in in one thing that you're going to look at right now is that Flutter framework, it's something that's giving you the ability to write code once, and then you're deploying it to 5 platforms. So as the Flutter framework continues to expand, so does the framework support for the various platforms we use in our daily lives, including smartphones, desktops, and laptops. And embedded systems is also increasing, and its growth will come the need to determine which platforms or users the solutions is being developed for, and the additional considerations such as maintaining the consistent user experience across these platforms without sacrificing the platform's design language and accommodating different screen sizes of the platforms. So we're going to delve into topics of adaptability and responsiveness in Flutter applications as we explore ways to tackle the challenges of targeting different platforms or devices. So let us look into one major thing, that is the difference between adaptive and responsive apps. They might sound to be similar, but let's get the difference. So there are three things with an adaptive app: it can run on different devices, e.g. mobile and desktop. Number two, it requires dealing with three types of inputs: there is mouse, there is keyboard, and then there is touch. So it requires using of platform specific features because there are different expectations from the app's visual density, e.g. top level windows or cascading menus versus bottom sheets for component selection. So let's look at a responsive app. A responsive app, it has its layout tuned for the available screen size, and then it needs relaying of the UI if the user resizes the window or changes the device orientation. So an interesting fact is that adaptability and responsiveness can be considered as separate aspects of an app. And the reason being, an app can be adaptive without being responsive, or it can be responsive without being adaptive. Additionally, an app can possess both qualities or lack them altogether. So it's important that you understand that an adaptive is different from a responsive app, and sometimes one can possess one particular aspect, and at the same time you can also have an app that possesses both, or it lacks all of them altogether. Um, I'll divide this session into two parts. The first one is that we'll talk about developing a responsive app. So, the second one we talk about developing an adaptive app. So, developing a responsive app, you'll realize that since Flutter allows you to create apps that self-adapt to the device screen size and orientation, there are two basic approaches to creating Flutter apps with the responsive design. Number one, you can use the LayoutBuilder class, and then number two, you can use the media query off method in your build functions. And let's go into the layout builder class. So from the builder property, you get a box constraint object, and then you examine the constraints properties to decide what to display. For example, if your maximum width is greater than your width breakpoint, you return a scaffold object with a row that has a list on the left. If it is narrower, you return the scaffold object with a drawer containing that list. So um, it's something that will actually, you already have all these things in place, but depending with how the screen will be resizing, you'll be able to switch and show the appropriate component or widget that fits with the screen size of at that particular moment. Then you can also adjust your display based on the device height, aspect ratio, or some other property. So when the constraint change, for example, the user rotates the phone or puts the app into tile UI in Nougat API, the builder function will run. And a sample code base here is very simple that you can see here. I'm actually trying to find the screen size. For example, I want to see the size when maybe the app is running on a desktop or on a tablet or on a large mobile screen, or even for example when it is tilted. So this is what we'll do here using the layout builder. And you can see in the builder it finds the context as well as the size. So this inside the size, you can access the attributes of maximum height, maximum width, and minimum width. So layout builder is as simple as that. Let's look at the media query method in your builder functions. So the media query method gives you the size orientation of your current app. This is more useful if you want to make decision based on the complete context rather than on the size of your particular widget. It's important to note that if you use this, then your build function automatically runs if the user somehow changes the app size. And a sample code base is there, whereby you see I'm actually trying to I've given a constant value of the large screen size, that is 1024, and I've given a medium screen size of 600. So a responsive widget, for example, it is a stateless widget. It will be able to check if if it should be showing a large screen widget, a medium screen widget, or a small screen widget. And then in this example, we will consider desktop as a default, hence it will be the required in terms of finding which one to show. So this is a widget that will actually be calling in another widget somewhere, and these are the parameters that will be actually passing, and large screen will be default. And going further, we'll be checking if the screen width is greater than or equal to large screen size, then we'll return the large screen widget. Else, if it's less than the large screen size and the screen width is larger or equal to the medium screen size, then return the medium screen, or the fallback will be large screen. So even else, in the else condition where we will be returning the small screen, still the fallback will be the large screen. So there are other useful widgets and classes for creating responsive UI. So number one, we have the aspect ratio, we have the custom single child widget, we have the fitted box, we have the fractionally sized box, and we have the medium query data, and of course we have the orientation builder. I encourage you, or I invite you to go and explore these widgets. Probably you've never thought about them, but if you start to employ them in your code base, you'll realize how your app can actually be responsive and how your app will be able to give a better user experience to whoever will be using it. So uh, go try out these widgets. They will probably change how your design experience of the app will be. Let's go to an adaptive app. So an adaptive app is something that I I tend to be working with most of the time because I'm building an app that is be able to run on mobile and at the same time run on desktop, and of course web is also factored in there. So Flutter offers the ability to create apps that can be used on multiple platforms, including mobile, desktop, and the web, using a single code base. However, this presents new challenges in creating apps that are not just multi-platform, but also adapt to each platform to provide a familiar and seamless user experience. So as we get into this subject, I encourage you to check the original demo of the adaptive app that was built by the G Skinner team. Um, this link, I think, it will be shared to you somewhere, either in the chats or in a tweet somewhere, so that you can be able to access this uh, demo, and actually you will be able to play around with an adaptive app. Gskin have really done a lot of impressive work in scaling Flutter desktop demos, and they have some impressive plugins or packages that they have made available to us. And if you checked in the Flutter Forward event, they did a demo there using an app called Wonders. And Wonders is a very good app that you can actually use to explore and see how an adaptive app actually behaves, or how you can actually get into it. So check it out. So there are three things that we'll be looking at in here. Developing platform adaptive apps, it will involve taking into account various factors, and this can be grouped into three main categories. There's the layout, there is the input, there is the idioms and norms. So layout is normally where most of us will normally focus. Then input, it will include things like mouse, keyboard, and even touch, and then even hoovers and context menus. Then idioms and norms, those are some of the things that we that are normally tied to particular platforms. So there are things that are actually expected in a certain platform. Could be the mobile, could be iOS, or could be Android, could be desktop, Windows, could be Linux. Yes, so that is it. So building an adaptive app, you will realize is that when you are developing an adaptive app, one of the initial consideration should be how to adjust the app to fit varying screen sizes and dimensions it will be used on. So there are types of layout widgets that we look at into. Then there's the visual density, then the contextual layout, and then of course, last but not least, there is the single source of truth for styling. So in types of layout widgets, they could be either single child or multi-child widgets. So the single child widgets are like align, aspect ratio, constraint box, custom single child layout, expanded and flexible, fractionally sized box, layout builder, and the single child scroll view. Um, there is an article that I've written on Hashnode about this particular topic, this talk that I'm giving, and the link will be shared to you so that you can actually go and see in depth what these widgets are to do with, or what they actually do. Because of time constraint, I might not be able to go into each one every one of them. Uh, in multi-child widgets, I know most of us, we have already interacted with the column, we've interacted with the row, and even probably you've also interacted with the flex. So there is the custom multi-child layout, then there is the flow, there is the stack, there is the table, and then there is the wrap. You will realize maybe there are some that you've not taken time to look into them. I invite you to go and actually explore them and see how they will improve your app user experience or design overall. Visual density is something that to do with the precision of the various input devices, and it varies, leading to the need for different hit area size. And the Flutter visual density class simplifies adjusting new view density through the app, such as making a button bigger on touch devices for easier tapping. So with a change in visual density for the material app, the density of supporting material components will animate to match. The default for both horizontal and vertical density is at 0.0, but they can be set to any negative or positive value desired, changing between densities, allowing easy UI adjustments. So this is a small illustration to show how visual density is actually applied. This is basically a desktop app, but um, the same thing can actually be demonstrated even on a mobile app. And a simple code base that you can actually explore to see how these visual densities are is actually used is there is the touch mode, whereby you check if it is in touch mode, and you increase the visual density or you reduce it. So visual density can actually be applied when you are initializing your app in the main.dat file inside the theme data. So it's something that you can actually add in your demo app and see how it actually works. And then inside your views, you can employ the visual density like this, whereby you say visual density equals to theme of context visual density. Yes, you can actually use it inside your views. We look at the contextual layout. Contextual layout, if you need more than density changes and you can't find a widget that does what you need, you can take a more procedural approach to adjust various parameters, calculate sizes, swap widgets, or completely restrict your UI to suit a particular form factor. So there are screen-based breakpoints, and then you can also use the layout builder for extra flexibility, and then you can also use device segmentation. Uh, Let me talk about some of these things. For example, the screen-based breakpoints are best used for making top-level decisions in your app. Changing things like the visual density, paddings, or font sizes are best when defined on a global basis. You can also use screen-based breakpoints to reflow your top-level widget trees. For example, you can switch from a vertical to horizontal layout when the user isn't on a handset. Then you can also use the layout builder for extra flexibility. Even though checking total size is great for full screen pages or making global layout decision, it's often not ideal for nested subviews. Often subviews have their internal breakpoints and can only about and care only about the space that which they are available to render. So that's a very simple way of actually handling something for a subview. So in device segmentation, there are times when you want to make the layout decision based on the actual platform you are running on, regardless of the size. For example, when building a custom title bar, you might need to check the operating system type and tweak the layout of your title bar so that it doesn't get covered by the native Windows button or window button. A single source of truth for styling. You'll probably find it easier to maintain your views if you create a single source of truth for styling values like padding, spacing, corner shape, font sizes, and so on. This can be done easily with some helper classes. A simple thing here is very simple that you can actually use. You can create a class, namely insets, and inside it you create double uh, constants, for example, of extra small, small, medium, and large, and even the fonts that you're actually going to use and the text style that you're going to use. So this one, they will actually help you in your code to actually maintain uniformity throughout your code, because you'll not be hard coding these things. You'll actually be referencing them from where you have actually saved them. Building adaptive inputs. Adapting the appearance of your app is not sufficient. You must also accommodate different user inputs. So the mouse and keyboard add input methods not found on touch devices, such as you can now find the scroll wheel, right click hover interaction, and then there's the tab traversal and the focus interaction. So keyboard, there are also keyboard accelerators and mouse enter, exit, and hover. And let me look at let me talk about each of these in a nutshell, so that you can understand how they actually affect your adaptiveness of the app. So in the scroll wheel, for example, widgets like scroll view or list view, they support the scroll wheel by default. As a result, nearly all the custom scroll widgets which are built using these widgets also work with the scroll wheel. So for custom scroll wheel behavior, you can utilize the listener widget, which will enable you to customize how your UI interacts with the scroll wheel. Then we come to the tab traversal or the focus interaction, and users who use physical keyboards anticipate the ability to use the tab key for quick navigation in your app. Additionally, users with motor or vision impairments often solely rely on the keyboard navigation. So these two considerations for tab interaction, they are like the tab traversal. You focus on how how moving from one widget to another, and then the visual highlight, which is shown when a widget is focused. Then we go to the keyboard accelerator. Aside from the tab traversal, desktop and web users are familiar with the keyboard shortcuts. They are assigned to specific action. For example, include the delete key for swift deletion or control N for creating a new document. It's important to take into account the various shortcuts that users expect. Yeah, so the things that Flutter actually has in place are the raw keyboard listener, then the shortcut widgets, and then there's the global listener. All these, they are actually in my article on Ashnode. And then there is a mouse enter and exit and hover. So on desktop, it's common to change the mouse cursor to indicate the functionality about the content the mouse is hovering over. For example, you usually see a hand cursor when hovering over a button, or an eye cursor when you hover over text. So the cursor can change from within your own widgets. In that one, you will use a mouse region. Mouse region is a widget that will actually be able to manage your cursor movements depending with where your cursor is actually hovering on. Idioms and norms. So the final area to consider for adaptive apps is platform standards. Each platform has its own idioms and norms, and these nominal or de facto standards inform user expectation of how an application should behave. Thanks in part to the web, users are accustomed to more customized experiences, but reflecting these platform standards can still provide significant benefits. So number one is that a minute, need to sort something here. Okay. By matching the user's existing mental model, accomplishing tasks become intuitive, which requires less thinking and boosts productivity and reduces the frustrations. So consider expected behavior on each platform. For example, it could be web, it could be desktop, it could be Linux, it could be Mac OS, it could be Android, it could be iOS, it could be an embedded platform. Their expected behaviors on each platforms. So one thing to help you, if you are developing an app that is supposed to be adaptable or portable, you need to find a platform advocate. And then this platform advocate is just like somebody who will actually be helping you to ensure that whatever you are developing is actually is actually conforming to that platform. Ideally, your advocate uses the platform as their primary devices, and they can offer this perspective of a highly opinionated user. To reduce the number of people, you can actually combine roles or have one advocate for Windows and Android, one for Linux and the web, and one for Mac or iOS. So their goal is to have a constant informed feedback so the app feels great on each platform. Advocates should be encouraged to be quite picky and calling out anything they feel differs from the typical application on the devices. A simple example is how a default button in a dialog is typical on the left of a Mac and Linux, but is on the right on Windows. Details like that are easy to miss if you aren't using a platform on a regular basis. Now, another thing is to stay unique. Conforming to expected behaviors doesn't mean that your app needs to use default components or styling. Many of the most popular multi-platform apps have very distinct and opinionated UIs, including custom buttons, context menus, and title bars. The more you consider styling and behavior across platforms, the easier developing and testing will be. The trick is to balance creating a unique experience with a strong identity while respecting the norms for each platform. So, common idioms and norms to consider. Number one is the scroll bar appearance and behavior. Desktop and mobile user experiences scroll bars, but they expect them to behave differently on different platforms. Mobile users expect the smaller scroll bars that only appear while scrolling, whereas desktop users generally expect omnipresent larger scroll bars that can click or drag. Did you know that? I thought you should know that. Yeah. Um, Multi-select. There is touch versus non-touch. Dealing with the multi-select within a list is another area with subtle differences across platforms. So you need to perform platform aware check for control or command, and you can write something that will be able to check the platform. If the platform is macOS and the key and the key is down, there is something that will do. If it's down, if it's not down, there is also something that you'll also do. Yeah, that is when you are selecting, maybe in a grid or in a table view. And then there is the selectable text. A common expectation on the web and to a lesser extent desktop is that most visible text can be selected with the mouse cursor. When text is not selectable, users on the web tend to have an adverse reaction. Luckily, this is easier supported with selectable text widget. So you need to look at the selectable text widget. It will help you in making your text to be selectable if it's on web. Then title bars. On modern desktop application, it's common to customize the title bar of your app window, adding a logo for stronger branding or contextual control to help save vertical space in your main UI. So this isn't supported directly in Flutter, but you can use the Bits Dojo package to disable the native title bars and replace them with your own. Context menu uh, is a typically triggered by right click and the context menu is positioned on the close. It's positioned close to the mouse and is dismissed by clicking anywhere or selecting an option from the menu. Then there's the tooltip, typically triggered by hovering for 200 to 400 microseconds over an interactive element. Then there's the pop-up panel, uh, also known as the flyout, similar to a tooltip. A pop-up panel is similar to usually anchored to a widget, and the main difference is that the panel are most often shown on a tap event, and they usually don't hide themselves when the cursor leaves. Instead, the panel is typically dismissed by clicking outside the panel or pressing a close or submit button. Horizontal button order. On Windows, when presenting a row of order, the confirmation button is placed at the start of the row or the left side, but on other platform is on the opposite. The confirmation button is placed on the end of the row or the right side. You can check that on iOS as well as on Windows or Mac OS. I'm saying Windows and Mac OS. You will see there's a difference. Menu bar. Another common pattern on Windows app is the menu bar. On Windows and Linux, this menu lives as part of the Chrome title bar, whereas on macOS it's located along the top of the primary section. Currently, you can specify the custom menu bar entries using a prototype plugin, but it's expected that this functionality will eventually be integrated in the main SDK. Yeah, I think I saw something on Flutter forward presentation. They have integrated a menu bar that you can actually use in your Windows app or in your desktop app. Yeah, I think it should be available in the next update, or it's already available. I haven't checked because I was actually using my customized way. Actually, I was following design, so in my designs they didn't factor in putting the menu bar the way it is on Windows. Drag and drop is another place that one of the co-interaction for both touch based and pointer based inputs is drag and drop. Although this interaction is expected for both types of input, then important differences to think about when it comes to scrolling list of draggable items. So that is subject uh, the one is the subject that we can actually discuss in more details in future. But today I was actually looking at how you can actually make your app to be portable, or how your app can uh, be able to adapt to different screen sizes. There is a link to my 3-part series of articles that I've written about Flutter portability, and it's entitled "Developing Flutter App for Every Screen." So you can if you have any questions, you will be able you can text me on LinkedIn or on Twitter. My handle is on Twitter is Jack0ke, and LinkedIn you can still find me as Jack0. I'll be able to answer your queries, and we'll be able to build an awesome Flutter experience. So I'll actually be while this session will be going on, I'll be following up in case things come up uh, in uh, in the chats or in wherever place they will be people will be posting their responses. I'll be able to follow up, and it'll be good to answer your questions as they come along after the session, not during the session. So I wish you all the best in your Flutter journey, and in trying to make your app to be portable, and making your app run on every platform. I'm actually working on an app for a client, and I opt to work using Flutter Desktop, and so far so good. I'm not struggling with coming up with the with the controls, or widgets as we call them in Flutter. So it's an awesome experience. uh, the future is definitely Flutter, and that is why we are saying Flutter forward. Thank you. Bye bye.